Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 34, Types of Chemical Reactions, Part 9. Here are our objectives for today's video. Pause here. So when we are balancing redox reactions, of course we have to balance the atoms just like we would in any other balancing equation, but you also have to balance the electrons. And the way that you do that is by separating the oxidation and the reduction into what's called half reactions, where you have electrons either as products in oxidation or reactants in reduction. Pause here. So when you're once you've written out your half reactions, you must balance the electrons. So for example, in the slide prior, I would have to put 2s in front of everything that contains silver because I need to have 2 electrons to balance out the 2 that came from the copper. But before you do that, so in a half reaction, it's not going to happen for the next 2 examples, but the last example of this video, you'll see what I mean for this. You have to balance the atoms before you balance electrons. That is only true within a half reaction. Once you have your half reactions, that's no longer true. I'm going to explain that using an example because I think on its own, that's kind of a confusing thing to say. Pause here. So let's start just by writing out the half reaction. So iron here is oxidized. It's going from 0 to +2. And then silver is being reduced. It is gaining an electron. Okay, so in my overall, I'm going to need to double everything that contains silver. And I don't need to do anything to iron. That is completely balanced as is. Upon first glance, you might not have thought to put the 2 in front of the silver. You wouldn't know that until you wrote out the half reactions. Pause here. I'll work through this one as well. Right, so nickel is oxidized here. It is losing 2 electrons. Cobalt is reduced. To cobalt with a 2+ charge. So a similar thing here, I'm going to need to double everything that contains cobalt in order to have 2 electrons. Now I'm going to show you a slightly harder example. I'll work through this one with you. So before I actually do the example, I just want to point out that you could rewrite the question and it might make your life a little bit easier. So even though it's a solid, you could really think of this as being 2Al3+ and 3 oxygens with a 2-. You could, that might make your life a little bit easier. Again, even though that's not really what it is, you can think of it that way. That's why I'm going to remove that because that's not really true per se, but I wanted you to have seen this. Okay, so let's just say I'm working with the oxygen. Before I balance my electrons, I actually need to balance my oxygen atoms. So I've got 2 oxygens, each with a 2- charge. So I'm balancing it based off of the number on the left. The reason why I am doing that is because O2 is covalent, whereas Al2O3 is ionic. So you always keep subscripts from things that are covalently bonded. Then I can deal with balancing electrons. So each one of them is taking in 2 electrons. Overall, 4 electrons are taken in. And then you might be thinking, well, you kept the subscript before, why aren't you keeping it here? And that would be a good question. The reason why I am ignoring that 2 is because that is coming from the fact that I need, that Al2 is coming from it being ionically bonded. So we really don't use subscripts if they are ionic, and we do keep them if they are covalent. So next thing I am seeing is that my oxygen, I need to have 3 of them. And my aluminum, I have to have 4 of them. And then lo and behold, if you take a look at this and you put a 2 in front, everything will be perfectly balanced. If you get to a point where it is conflicting, like you can't just put an even number in front of something that's ionic, that means you probably made a mistake. It should always work out nice and evenly, just like this with whole numbers. These problems can be particularly challenging for some students. We're going to do a fair bit of practice in class with these. So if you're still having a little trouble with it, we're going to do some more practice in class. Great. Thank you so much for watching, and have a great night.